Hello friends, I welcome you all to this session on C programming. So in my one of the previous videos, I have introduced you with functions, how to write the functions. I'll give you the I give you the link for that particular video in the description of this video. Now, in general, while writing a function, you should have name of the function, then the arguments, then the body of the function, and if the function is returning something, then its return type, and then return. Now that is how we write a function. Now in this particular lecture, what I'll be doing is I'll be taking two programs. One is to swap two numbers. Another one is for writing a function for finding out the value of sine theta. Now if you think of swapping, so there is one simple way that, let's say A is 2 and B is 4. Then how can I swap? So let us take one variable k, and let's say right now it doesn't have any value. Then what I'll do is I'll assign the value of a to k so that it becomes now 2. What I have done is I have assigned the value of a to k. Okay. Then I will be assigning the value of b to the variable a. That means a will now be holding the value of b, and the value which was with k will now be taken up by b. So that is b now will be taking the value of k. So first I'll be doing this, then I will be doing this, and finally I'll be doing this. So in this way, what will happen? The values will be swapped. Now let us move to the editor and let us write the program for it and then make the function of it. And then I will tell you that how the function really works. So let us say I am having two variables a, and I am giving the value here itself, let's say 4, and variable b is having, let's say, 7. Now I also want to have this intermediate variable k. Then what I'll say, I will assign the value of a to k. Then my second task was to assign the value of b to a. So now a will be holding the value of b, and this finally the b will be holding the value of k. And if I print this now, percentage d, so this is what a is and this is b, and in the first place a will be coming, in the second place b will be coming. So if I run this program, so now previously a was 4, b was 7, but now a is 7 and b is 4, so they are swapped. Now I am interested in writing the function for it. Let's say this is basically swap, swap, and then it is requiring two arguments. Okay, so let's say a and b. Okay, then what? Then this is basically doing what? Now look, I'll take everything inside and then do this. What I have done, I have transferred the program itself into this. Now, is the program returning anything? No, right now not. So, I will be simply saying void, don't return anything. Now friends, this is a very important thing to understand. If I simply say swap and then transfer the value of a and b whichever is right now here, so a comma b, then what I am expecting? I am expecting that this the value of a and b will be transferred to here and they will be getting swapped. So let us see what happens. So now a is 7, b is 4. So you must be thinking that the values are swapped. You know what? They are not at all swapped. Still a is 4 and b is 7. So what is happening here? So to make you understand what is happening, let me write something here. Printf uh, after swapping, and then new line. Here also I'll write new line, and then what I'll do is I'll print again the value of a and b so that it becomes clear to you. That's it. So now if I run it program, if I run it now, so initially, so okay, I have to write initially also. So let me do it here. So before swapping, and then before swapping, this is the value. Then after swapping or using that function, something I'll be getting. And then what is happening after swapping, let us try to understand. Now look very carefully. Before swapping, the value of a was 4 and b was 7. The moment I called the function, a becomes 7, b becomes 4. Does really it happen? No. It only printed this statement. That is, it swapped inside this function and then printed that value. And after swapping, still the value of a is 4 and b is 7. So what you have done is, basically, what have you done? Friends, this is what we call as, we are calling a function swap by using the values of the variable. And if you are thinking that this a is coming here, this b is coming here, so you are wrong. What is happening in principle is, the value of a, that is 4, will be copied here, not the variable. Then the value of b, that is 7, will be copied here. So we are calling this particular function by giving the values of the variable. So this is called by value. Okay, so a is copied here, b is copied here, and then the copies of a and b, they are, which are transferred to this swap, they are taken by this function. Then the function is doing some juggling inside and printing something. So as copies are being transferred to the function, so do you really think that the variables which are holding the value, that value has changed? No, not at all. This is very simple, friends. Let's say I am having maths notebook and physics notebook. Okay, now you are interested in that subject. You took my notebook and you xeroxed it, returned my notebooks back to me. So if you are writing anything in your copy, then how come that affect the notebook of mine? So my notebooks will remain intact. You are just playing with the copies, and that is what call by value is. So how to solve this problem? In principle, my variables are getting swapped. They are just being printed by this particular function and giving me a feeling that they are swapped. Friends, this is the problem which basically led to the development of pointers. So in principle, if you want to, let's say, change something in my notebook, then what you should have? You should have the right of my notebook. That means you should have that notebook, and then only you will be able to write or scribble anything on it. So what I have to do here is, instead of playing with the copy of that notebook, I should have that notebook. Means, in terms of programming, instead of playing with the value or the copy of that particular value of a variable, I have to go to the address of the variable, change the value, and then only that particular thing will be changed. So remember, this particular program is not swapping the value, it is just printing the swapped value, that's it. Okay, so I hope this thing is clear to you, and how to do it in principle correctly, that means how to really swap it, that will be done with the help of pointers, which I'll teach you sometime later. Now let us try to write another function. Let's say I'm interested in writing the function for sin x. Now, you know how to do it, we have to do it numerically. That means we have to use the method, that is series. Now, what is sin x? It is x minus x cube by 5 factorial, then plus x to the power 5 by, sorry, x cube by 3 factorial, plus x to the power 5 by 5 factorial, minus x to the power 7 by 7 factorial, and so on. So friends, if you want to generalize this thing, what you have to do is think like, now rewrite this as x by 1 factorial to the power 1, then minus x cube by 3 factorial, then x to the power 5 by 5 factorial, minus x to the power 7 by 7 factorial, and so on. Now, if you look closely, let's say I'm interested in writing, basically this is nothing but a sum. Hai. So, if I want to write this, then I have to generalize this sum. Let's say my loop is starting with 1. Okay, my loop is starting with 1 and it is going till that particular term. Let's say starting with 1, 2, 3, 4. So, 4 term sum I have to use. Then how to generalize it? Now look very closely. My loop index will go from 1, 2, 3 and let's say 4. So when I is 1, I should be getting this. When I is 2, I should be getting this. So how to interpret these powers? So when I is 2, I am getting 3. How to do it? So think in this fashion. If I write it as 2i minus 1, then what will happen? If I is 1, so this, if I is 1, let me write it here. If I is 1, then 2i minus 1 will be 2 into 1 minus 1, that is 1. If I is 2, that is 2 2s are 4 minus 1, that is 3. If I is 3, then 3 2s are 6 minus 1, it's 5. Very good. So, the power part as well as the factorial part is done. What about this negative? Friends, if you look it closely, for I is 1, this is positive. For I is 2, this is negative. So I can't say that minus 1 to the power I. The first thing. The second thing is that when I becomes 2, it is negative. How to make it? How to make it? Think. When I is 2, then that is negative. That means it is coming like something which is odd number, isn't it? And here it is getting even, because minus 1 to the power odd is negative, whereas minus 1 to the power even is positive. So therefore, if I write minus 1 raised to the power I minus 1, then the problem will get solved. Because if I write I minus 1 also here, so when I is 1, I minus 1 will be 0, and minus 1 to the power 0 is what? 1. When I is 2, then 2 minus 1 is 1. So minus 1 to the power 1 is minus 1. So that's why I am getting this minus 1. So therefore, if I generalize this, so it will be minus 1 to the power I minus 1, then x to the power 2i minus 1 and the factorial of 2i minus 1. And then sum it up for I is equal to 1 up to that particular term where you wanted, or up to what term you require in that series, because more the number of term, the better the result will be, isn't it? So how to do this? How to write this program? So for this program, you should have two functions, not one. The first function is for the factorial, and the second function is for your sine. So what I'll do is, I'll first write factorial function, make a program for sine, and then convert that sine again to your what we say as a function. So how to do that? So let us start. So let us head to the editor. So this I don't require anymore, and here I'll be removing everything. Let us start. Let us start that first. I'll be making a program, sorry, function known as fact, and I will be transferring one number to it, and then it has to be what, integer. Okay, return type has to be integer. So inside, let's say I declare one I as well as f. Okay, now look, initialize f with, or oh, it doesn't matter. So if let's say n is 0, then you know 0, what is 0 factorial? 0 factorial is basically 1. So f will be 1. Very good. Now, else if it is not 1, let's say I am not giving negative numbers. So else what will happen? Else you will be starting with f as 1, and then you will be running a loop. That is, for I is 1, I is less than or equal to n, I plus plus. This program I have already done for you. Then what you have to do? You have to simply multiply this f by I and assign it to f. That's it. So once this part is over, that means this whole is over, then this is for else, and once this is over, then I have to return this f. So let us check whether it is working properly or not. Printf %b, comma, factorial, this is fact, na? Factorial of, let's say I am interested in 3. So you know the factorial of 3 is 6. So it is coming out as 6. Check one more. It is 4, let's say it is 24. Okay, so this program is running very well. So now my function for factorial is absolutely correct. Now I have to go for the program where I have to find out the series sum. And sum you already know. It is nothing but -1 to the power I minus 1 x to the power 2i minus 1 by 2i minus 1, I starting from 1 and going up to that particular number n. Okay. Now, first I require how many terms in the series? Let's say I am giving it here itself. Let's say I am taking 5 terms. Okay. Then what else I require? I have to have that index I. Okay. I have to have that index. I can declare this inside the loop as well. That's not a problem. Let us do it. I'll do it inside the loop. What else? I have to have that x or theta value. Let's say I'm giving it here. You can write your printf scanf functions, no problem. So let's say I'm interested in 90. Sine 90 is, you all know it is 1. Okay. Apart from this, I will be having this sum, and I will start with 0. Then, friends, remember, all the trigonometric functions, the argument has to be in radians. Yes. Then I have to convert this x into radians. So how? By multiplying it by pi by 180. What is pi? It is 3.14 divided by 180. Very good. Once this is done, now you can run your loop. So for int I is 1, I is less than equal to the number of terms in the series, and then I plus plus. If you look here, so I is starting from 1 and going up to that term which is required. So how many terms I require in the series? That will be my n. Then inside this for loop, what you will do? You will simply say s assigned s plus. Now look, this is -1 to the power I minus 1. So let us use math module also. And here I will write power -1 raised to the power I minus 1. Okay. And then I will multiply it by, if you look here, it is x to the power 2i minus 1. So again, power x to the power 2i minus 1. Okay. Then I have to divide it by the sorry friends, this is nothing but 2i minus 1 factorial. So 2i minus 1 factorial. So I have to divide it by, now I will be calling my function fact factorial of 2I minus 1. That's it. Done. So now the time is to print the sum. Printf, then percentage, sorry, sum, series sum is equal to percentage f, because s is float. Okay, and then I'll simply say s. So let us run it and see. The answer is 1.0000. Now why this is? This is just because of truncation error. We have taken less term. Let's say instead of 5, if I take let's say 10 terms, then the result could have been something else. So instead of 10, if I take let's say 20 terms, then it is now. Now friends, remember why this is happening. This is happening because of the inefficiency of this particular variable int to hold more data. So this error is coming because, not because of any logic, not because of any wrong thing we have done. No, we have done everything correct. But the thing is, the ability of this f to hold data is limited, and I have to use modifier. So long int or long int I have to use. Okay. So let us restrict ourselves to only let's say 6 terms or 7 terms. So it is 1. Oh, in the 6th term it is getting, we are getting 1.000 and so on. So friends, in this way this particular thing works. Now let's say I want to make this as a function. How to do that? Very simple. Let's say float and then make it sin, because in math module sign is already defined, so we will be making it uppercase. And here what I want is that particular variable whose value I want to get, or whose sign I want to get. So let's say it is float x is the one, and then the body of the sign. So here what is required? Also let us take int n, the number of terms in the series that let's say I am also taking. Then inside I'll take for the I should have this. Okay, so I'll bring this inside this function. Okay, so I have to declare. So x is already there, so x we are converting it, no problem. Int is, so s has to be declared here. So let's say float s. Then what? Then you just have to return s. That's it, and you have to initialize it with 0. I think that's all what we require. And here inside there is no point of writing this s. We simply now look how elegant this program becomes. We just have to pass the number of terms in the series, then the value x, and then let's say this time I'm saying sine 30. You know it is 1 by 2. So the series sum is nothing but I'll be calling this function, that is sine, and this function requires what? X, which I have already taken as 30, and then the number of terms, which is what? 6. So friends, what it will do, sine function will be what is called as the called function, and this main is the calling function. So main called this function sine inside it, and the copies of n and x will be transferred. So this is what we call as call by value, and then it will be returning the value. That's it. So if I run it, so it is 0.499770. So it is close to 0.5. Again, first we have two differences. First the value of pi, another is the number of terms. So if I increase from 6 to let's say 7, then I will be getting 0.49977. So it is more close to 0.5. So in this way you can write your functions. Okay, and in the next class I'll try to make you understand about recursive functions, and we'll be writing some more programs there. So thank you very much for watching it. Take care.